In this presentation, we'll be discussing graphene and its application to gas filtration. This presentation was made by Emily Lewis, Jordan Rogas, Jason Valenzuela, and Penny Williams. An issue that our society is dealing with now is a lack of clean energy sources. Our main energy sources are fossil fuels, which have many negative effects on the environment, the main one being the emission of greenhouse gases, which contribute to global warming. Although we do have clean energy technologies such as wind turbines and solar panels, it does not create nearly as much energy as fossil fuels to sustain our energy demands. They also rely on factors that we cannot control, such as steady wind flow for wind turbines. For any gas to be useful, it must be purified. Current filtration technology includes a membrane structure that allows certain particles to pass through, which separates desired components from the mixture from undesired components. Current membranes are made of compounds and elements such as titanium dioxide, palladium, and silver. For clean energy purposes, the goal of the filtration system would be to yield pure hydrogen.
Clean energy is important to society and us because in the future humanity needs to find a suitable replacement for fossil fuels because 1. Fossil fuels are destroying the planet, and 2. We will run out of fossil fuels in the next century. Considering the habitual nature of humanity, it would be necessary to find an alternative solution in which everyone has the incentive to help fix the energy crisis, rather than suggesting just a mere limitation energy solution. For a clean energy technology to be plausible and effective, it must not require a change in current lifestyles, which hydrogen purification is capable of. There is a constant worry of the future of clean energy, and shifting to a hydrogen-based economy is a potential solution. This technique of filtration for hydrogen purification would provide a clean and renewable energy source. Graphene derives from graphite. It is a sheet of graphite that is 1 atom thick, making it among the world's thinnest materials. Its thinness proves a major challenge, as the materials that usually work with other metals are currently not compatible with graphene. So new techniques to process graphene must be explored. Graphene's atoms are arranged in a honeycomb shape, which leads to its unit cell that contains 2 atoms. In addition, graphene is strong, flexible, stretchable, and can carry an electrical charge through it extremely quickly. Graphene is a substance that was discovered relatively recently, around 2004, and shows amazing promise as a material that could be used in technologies from computer chips to fuel cells. Graphene was discovered in 2004 by Andrei Yim and Konstantin Novoselov. It was discovered through a process that will be seen in this video. They used tape and kept ripping off sheets from graphene until the sheet was about an atom thick. This disproved the theory that graphene was too fragile to have any structure at a thickness of 1 atom, leading to an explosion in graphene research.
Graphene is impermeable to gases as small as helium because of the electron density of its aromatic rings, which repel atoms and particles. In order to make graphene a membrane, synthetic pores must be placed in the material. This makes it more porous and allows diffusion of certain gas particles. This process is carried out by using an electron beam to break the bonds, making up the graphene line defect. The dangling bonds that result from this hole are passivated by adding a hydrogen atom.
In this video, we'll be showing an example of a good and bad filter. The bottle cap will represent the hydrogen molecule, while the orange will represent the carbon monoxide molecule. First, let's start with the bad one. As you can see, both the hydrogen and the orange molecule can make it through the filter, making it inefficient. Second, we have the good filter. This time, the hydrogen can make it through, but the carbon monoxide molecule cannot make it through the filter, making this a good filter.
One of the most pressing issues is how to produce graphene on a larger scale. Typically, the size of membrane technology for industrial use ranges from 1 to 1,000 square meters. Specifically for hydrogen separation, an industrial membrane is about 1 square meter. However, in many processing techniques, freestanding graphene membranes become ruptured once taken off a substrate. Currently, the most promising processing technique, chemical vaporization deposition, CVD, has created a graphene membrane that is half a millimeter in size and still retains its desired properties. While graphene has the potential to serve as a gas separation membrane, it still has a long way to go to become of significant use in the industrial and commercial world.
CVD involves using a carbon-saturated transition metal while exposed to hydrocarbon gas at a high temperature. Solubility of the carbon decreases as the substrate cools, causing a thin layer of carbon to precipitate on the surface of the transition metal. The resulting layer of graphene can be transferred to other substrates by wet or plasma etching the underlying transition metal. Current CVD technology is being developed to reduce energy consumption and prevent the formation of unwanted products such as amorphous carbon. At this point, everything is theoretical. No physical experimentation has been done to test the possibility of inserting hydrogen into the graphene line defects, and all calculations for this theoretical experiment were found using interpolation. Therefore, there is no existing process to create a usable graphene membrane for hydrogen purification.
Alright, so here's the problem. Currently, energy is a limited resource. However, fuel cells, along with hydrogen purification, introduce a possible source of renewable clean energy.
Using filtration, we can separate gases to produce pure hydrogen that then can be used to power fuel cells. The problem with this current technology is that it's difficult to totally isolate the hydrogen. Separating it from carbon dioxide and methane has proven difficult. Because of this, it is difficult to mass produce purified hydrogen.
Actually, creating the line defects with hydrogen is still in its research stage. The current technology with the greatest potential for mass-producing graphene is known as CVD. However, despite this, graphene in general is still difficult to make in larger amounts and sizes.
The current structure of graphene contains naturally occurring line defects. What we want to do is insert hydrogen atoms into these line defects. This would give graphene a new porous property that would prevent all molecules but hydrogen to pass through.